Good day everyone. Welcome to our class in Math 051, Engineering Calculus 1. So we are now in our part 7 of our review of functions. So today's discussion will be focused on the greatest integer function. So this greatest integer function is also called step function or the floor function. Okay, so we have this expression as y equal to f of x equal to the greatest function of x, and we have other symbols that are commonly used for the greatest integer function. So we have this symbol like this, okay, or we also have a symbol like this. So don't wonder why when you read different resources, so you will see different presentation or representation of the greatest integer function. And when you graph this function, you will see something like this. It's like a ladder. Okay, so the greatest integer function is the greatest integer less than or equal to x. So the symbol used is this one. And in our discussion, we are going to use the concept of integers. So let us recall first what are integers. When you speak of integers, these are set of uh, integers are the set containing the positive whole number. What are these positive whole number? Like 1, 2, 3, 4. Okay, so whole number. Example 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. And also 0. And the negative whole numbers. Okay, so these are the composition of the integer. So whole number or whole numbers, and 0, whole positive whole numbers, and negative whole numbers. Okay, so we have here examples, or let us take this first example. We have to graph this y, which is equal to the greatest integer function of x. Okay, so this is our example. Alright, so we have here values for x, and let us apply the concept of the greatest integer function. So we have to rounds down to the nearest greatest integer. So for example, we have here minus 2. So the greatest integer function of negative 2 is also a negative 2. Alright, so what's the reason? Why is it negative 2? So when you round off negative 2, that's also negative 2. But how about this negative 1.75? Okay, so to help us find the greatest integer function of negative 1.75. So let us draw the number line system first. Okay, so this is our number line system. So our negative infinity, so our positive infinity. So assuming this is our 0 here. Okay, so numbers going to the right of 0, positive. So 1, 2, 3, and so on. And on the left side of 0, we have the negative numbers, negative 1, negative 2, negative 3, and so on and so forth. Okay, so if you look at negative 1.75, so this is negative 1. So we speak of 0.75, 1.75. So this is 1.5. Okay, I'll change the color. So the 1.75 is somewhere here. This is 1.5 here. This is the 1.75. Okay, so 1.75. So if you look at, okay, so if you look at this number, we know that if we think that the closest number integer of 1.75, negative 1.75 is 2, or say 1, so we are wrong. Why? Because for the negative numbers, we know that the number that is closer to 0, no, the negative number that is closer to 0 is much bigger than the number that is farther than 0. Or another way of saying it, the the number that is farther from 0 is less than the number that is closer to zeros, and we are rounding down, no, we have to rounds down the number. So 1.75, when you rounds that down, so this is negative, so we're supposed to round this to what, 2 or 1? So what do you think? So this is a negative number. So negative number, when you rounds down it to the greatest integer function, so this should be negative 2. Okay, so if you look at the number line system once again, so this is our 1.75 here, so we runs this down, so it will become smaller, right? So 2 is smaller than 1, so we are not going to rounds it down to 1, though numerically 1 is smaller than 2, but in terms of the number lines, we see that negative 2 is farther than negative 1 in reference to 0. Okay, so negative 1.75 rounds down to minus 2. How about negative 1.5. Okay, so negative 1.5. So again, look at the number line. So 1.5 is here. Okay, now the greatest integer function of 1.75 negative, so rounds down, so not to 1, right? So that is also negative 2. Again, because negative 2 is smaller than negative 1. And how about 1.25? So negative 1.25. So our 1.25 is somewhere here. Negative 1.5 is somewhere here. So when we rounds it down, so not to negative 1, but again to negative 2. So our greatest integer function of negative 1.25 is also negative 2. How about 1? Sorry, this is negative 1. For negative 1, so that is also negative 1. Okay, so the greatest integer function is also negative 1. How about negative 0.75? So negative 0.75 is somewhere here. This is half of it. Okay, this is 0.5, so 0.75 is here. So we have to rounds it down to negative 1 also. And how about 0.5? So same, 0.5 rounds down to negative 1. Negative 0.5 rounds down to negative 1. How about negative 0.25? So negative 0.25 is somewhere here. Okay, so rounds this down to, so not to 0 because 0 is greater than 1. Okay, so this should be rounds down to negative 1 also. And how about 0? So 0 is rounds down to same, 0. Then positive 0.25. So now we're on the positive side. So this is 0.5. Sorry, 0.25 is here. Okay, this is 0.25. So when we rounds this down to, okay, so not 1 because when you rounds this to 1, so we are going it over. So it should not over. So it should be rounds to 0 and 0.5, and so do with 0.5. So 0.5, hindi siya pwedeng i-rounds down to 1 because it goes over. So it should be to 0. And 0.75, same, we have to rounds this down to 0. And then we have 1. Okay, so when x is equal to 1, so the greatest integer function of 1 is also 1. And if you have 1.25, 1.25 is somewhere here. This is 1.5, so 1.25 is somewhere here. So rounds this down to 1. So this is also 1. And 1.5, so 1.5 is here. This is 1.5, so when you rounds this down, it should be to 1. So 1 is the greatest integer function of 1.5. Okay, so we have now the coordinates x and y. So let's now plot the points. Now here in the coordinates x and y, so you've noticed here it is labeled already, but I think it's better if you have to remove the labels, the label to make it clearer, because it's very messy. So we have to delete this one. Okay, delete this one as well. So just know that the every unit there is equivalent to 1. Every division is equal to 1. Okay, so let's go now plotting the points. So for negative 2 and 2, so where is this negative 2 and 2? Alright, so negative 2 and 2, so this is our x is negative 2, our y is negative 2. So where is it? So where is negative 2 and 2? So x negative 2, so negative 1, negative 2, y is negative 2 also. So you go down twice, so 1, 2. So the point is here. Okay. Then for 1.75, so 1.75, so for x equal to 1.75, so 1.75 is somewhere here, negative 1, negative 1.5, so 1.75 is somewhere here, and we have also 2. Okay, so we have also 2 here. And then for 1.5, 1.5 negative, so somewhere here, so that is also here. Alright, okay, I'll just use a small point to give space. Okay, so let's do it again to give space for the others. Okay, so for negative x equal, so for x equal to negative 2, y equal to negative 2. So this is negative 2, y negative 2. So this is, it's here. Okay, and then for 1.75 negative, so 1.75 is somewhere here. So this is also here. And for 1.5, so 1.5, so negative 2 also, it's here. And we have 1.25, so 1.25 is here, so that is also here. Okay, or this is just a straight line, right? Then okay, let's proceed with other number. So we have negative 1, 1. So for negative 1, 1, so we have it here, this point. Then negative 0.75, negative 1. So 0.75 is somewhere here. Then this is also negative 1. Okay, so we have this point here. Then for negative 0.5, that is also negative 1. So half of it, so go down. So it's also negative 1. Okay, and then we have 0.25. So for 0.25 somewhere here, so this is also negative 1 here. Okay, next we have 0. So 0 is here. For 0, so that is also 0, so it means it's here. So the point is here. And for 0.25, so 0.25 is here, so it means the point is here. Then we have 0.5, so 0.5, the point is here also. And we have 0.75, that is also 0, so here. Then next we have 1, so when x is 1, we have the greatest integer function y equal to 1 also, so we have at this point. Then when x is 1.25, so the greatest integer function is also 1. Okay, so 1.25 is somewhere here, so this also, the point is here. Now when the value of x is 0.5, so the greatest integer function of x is, that is also 1. And when the greatest function of, when x is equal to 1.5, no, x is 1.5, so the greatest integer function of x is also equal to 1. Okay, so you see here, so this is just a straight line. Okay, so let's make another, or use other color. uh, so use this color here. Okay, let's use the green color. So this is just a straight line. Okay, so with emphasis that this is a solid one, this point here. Okay, and this is a hollow one, this is a hollow, and this is also a straight line with a solid part here, and this is a hollow one here. Okay, and then we have another one here, straight line with a hollow one here, sorry, a solid shaded, and this is hollow, and this is another one. So again, this is solid, and this is also a hollow. Okay, and then you just continue it. So that is the greatest integer function. This is a step function, or the floor function. Okay, so I think that's all for today for this, the greatest integer function. I hope you have learned something from today. I think this topic had already been discussed in your previous mathematics, so we are just reviewing it. Alright, so this is the graph of the greatest integer function. So if you look at this, so the leftmost is a shaded one, left end of which small lines is a shaded one, and the right end is a hollow. Right, so this is considered function because you see, if you're going to draw a vertical line, it will still pass the vertical line test. Say, for example, if you draw a line here, okay, so it intersect only at one point here. Now if you draw a line, say this one, if you draw this line, still it intersect only at one point because this is the shadowed point or the solid one, and this is the hollow. So it intersect only at one point of the function. Alright, so again for the domain, so if you're asked to find the domain of the greatest integer function, so the domain are all real numbers. And for the range, so the range are all integers. Alright, so thank you very much. That's all for today's uh, lecture review on the greatest integer function. So good day everyone, and see you again in the next topic. It's all about transcendental functions. Bye bye.